Good morning, mathematicians. We are thinking about our Tuesday column of week 26, and let's start off with thinking about some powers of 10. It says Dr. X Poland needs you to write the following as exponents. So we know, boys and girls, that exponents are those tiny numbers that boss the bigger number, the base. And it tells the base how many times to multiply itself together. So here we see 10 is going to be our base, and 10 is multiplying itself together two times. So we know that this really equals 10 to the power of 2. See that tiny bossy number that bosses the 10 to multiply itself together two times. Okay. Now let's take a look at this. Here we have 10 being multiplied together how many times? Well, the 10 is being multiplied together four times. That is 10 to the power of 4. Now, down below, this is a good opportunity to remember another way you can show those powers of 10 is in their value. So here, the value of this power of 10, of course, is 100,000. Well, one easy way I know how many to write as my exponent is to look and see how many zeros the number has, because we've noticed that pattern in our lessons. So here we have 10 to the power of what? Well, there are five zeros, so the exponent is going to be 5. Let's take a look at our next number, which is 1 million. And I know that 1 million is a 10 made up of how many zeros in my exponent? Well, that's going to be 10 to the power of 6 because I see 6 zeros in that number and I recognize that pattern to be true. Okay, let's come our very last one. Of course, we're going to have our exponent, or excuse me, our base is going to be 10. And when I take a look, there's 3 zeros, 6 zeros, 9 zeros. This is 10 to the power of 9. Okay, that was a good opportunity to think about the powers of 10. Now let's come and think a little bit about the metric system of measurement. We are given this value in meters, and we're asked to convert it into centimeters and then to also convert it into millimeters. So if your paper doesn't have an equal sign here, go ahead and write an equal sign because we are really doing another conversion. First, we're going to convert it to centimeters, then we're going to convert it to millimeters. Okay? Now, let's take a look at the very first one. Our first unit here we have is meter. And how many of those meters do we have? Well, we have 5/10 of a meter. So I'm going to think about those powers of 10. We've done this in multiple ways in class, but certainly we remember our base system of measurement for length in the metric system is the meter. And here we have 5/10 of a meter. We're going to convert that first to centimeter. So I'm going to go down one, two stairs. Really, what that means is like I'm multiplying it times 100 because every time I go down the stair, I'm multiplying by another 10, right? That is why we have learned that pattern to be true. Really, we can take our decimal from where it was with meter, and since I go down two stairs, I can move my decimal two times to the right because that is like multiplying by 10 to get to deci. This is like multiplying by another 10 to get to centi. Okay. I don't have a digit there, so I have to plug in a 0 as a placeholder, and that is centimeters. So far, I have learned that 5/10 of a meter is equal to 50 centimeters. But I now need to take that down one more stair to get to millimeter. We have learned that when we take that number, such as the 50 centimeters, and now move my decimal one time to the right, that is like multiplying it by another 10 when I go down a stair. That gets me to millimeter, which is the answer to that first question. So I'm going to come now and write that 5/10 of a meter is equal to exactly 50 centimeters and exactly 500 millimeters. Now, if I know that to be true, when I take a look at 7/10 of a meter and I'm converting to the exact same unit, I know that I'm going to be moving the decimal two times to the right to get to the same idea as I had here. right? So this is going to equal 70 centimeters. And this is going to equal 700 millimeters. Now take a look. I'm starting again at meters, 9/10 of a meter. So I'm going to move my decimal in the same way. I'm going to see that that equals 90 centimeters and 900 millimeters. Boys and girls, that finishes out our metric conversion question. And now we're going to get to a very unique way to look at multiplying decimals. I'm going to zoom in just a little bit. And first, we're going to notice above this pink line, we're studying someone else's problem solving. This does not have to be your chosen strategy for multiplying decimals, but it's interesting for our brain to take a look at someone else's idea and someone else's approach to see how it works for them. Let's notice that they're starting with these two factors and they're multiplying them together. So, boys and girls, what I'm noticing, and I'm going to come down below, is that here, those are the two factors I'm multiplying together. Now, this person really thought, well, let me see. If this is one decimal place on the end, this is a tenth. I can really remember that 23 and 2 tenths is the same as 232 divided by 10. Because 232 divided by 10, of course, would give me my decimal right there between the 3 and the 2, right? Instead of on the end. Well, I can also treat this 4 and 5 tenths the same. 4 and 5 tenths is like a 45 if we just knew that we needed to divide that 45 by 10. Now, they did that for this moment right here because they wanted to think about 232 times 45 and find the answer to be 10,440. Okay. But they had to remember that really those numbers had it divided by 10 here and another divided by 10 here, which really on the other side of the equal sign is going to be like divided by 100. That is why at this moment they take this idea and they came down below and they said, okay, I had these digits, but I really have to divide them by 100. And that is going to be these digits, but the decimal point moved 2 times to the left because I see I have 100 zeros. I have dividing, and when I divide, I become less. So I move that decimal point to the left. So I'm going to go in 1, 2 times, and really, this is the answer that they came up with. Their strategy is certainly a unique one, but must be more efficient for them to be able to think about that whole number multiplication. Now, where the challenge is that we are asked, let me come back up, below the pink line now, to use that same reasoning to do our own division problem. So here I'm starting with 41 and 5 tenths, and I'm multiplying by 3 and 6 tenths. So I'm going to use the same strategy. I'm going to take 415. I'm going to remember that that's really divided by 10 in my factor. And I'm going to multiply that by 36. But remember that that's really 36 divided by 10. And I'm going to now multiply 415 times 36, which I'm going to let you pause the video and do with whatever your chosen strategy is. Resume the video after you've shown the work for 415 times 36. Now, 413 divided by 36, or excuse me, times 36 is going to give us these digits. But these digits aren't in the right place value yet, because what I need to do at this moment is now divide them by 100 because I really had divided by 10 and divided by 10 over here, which on the other side of the equal sign, we're going to combine that to be divided by 100. So just like we did before, we're going to take this and we're going to come down here and we are now going to take what looks like 14,940 and we're going to divide it by 100, which equals those same digits, but with the decimal point. Move to the left 2 times. 1, 2, I'm dividing, so it's becoming less. I'm moving it to the left, and I'm moving it 2 times because this is 100, 2, 0. We know that pattern to be true. So notice, boys and girls, I have now solved this, and I have found my answer. I'm going to circle it so that it's clear what I found that final answer to be. My final answer is 149 and 40 hundredths. Interesting strategy for sure. Interesting strategy for sure. Doesn't have to be your go-to method, but certainly it's good for our brains to have to stop and ponder someone else's problem solving. It really stretches us to almost think like a teacher and be able to reflect and consider a different approach. Speaking of a different approach, let's take a look at this way of subtracting decimals. In this strategy of subtracting decimals, which we've tried a couple times now, we are actually counting up. So I'm starting at this 84 and 22 hundredths, and I'm going to count up until I get to 132 and 65 hundredths. Okay? Now, when I look at this, it kind of excites me because I can do this in 2 steps, this count up. I notice that here I have 22 hundredths and here I have 65 hundredths. That's very close. In fact, if I simply jump a tiny bit right here, if I jump exactly, I'm going to write this down for us. If I jump 43 hundredths, see 43 hundredths, this hundredth is going to become a 5. This 2 tenths is going to become a 6 tenths. And notice in my very first step, what I did is I started with 84 and 22 hundredths. I actually added 43 hundredths. And what it becomes is, take note, 84 and 65 hundredths, which is my target decimal value to get to. Now, all I have to do is one large number line leap. And in this large number line leap, I'm going up exactly 48 wholes. Interesting approach again. We have starting with 84 and 65 hundredths. Now I'm adding 48 wholes, and notice in that one big step, I get all the way over here to 132 and 65 hundredths. The last thing that I must do in this approach is figure out exactly what it was that I jumped. So I'm going to combine those things together in my last line. I had 43 hundredths. I had 48 wholes. Together, that gives me 48, the whole number value, and 4,300, the decimal value. Take a look. That's counting up instead of lining up your decimal points, bringing them down, and pursuing it with that standard way of subtracting decimals. All right, one last question. We have persevered today through some interesting questions and stayed focused. Let's finish strong with this one. Interesting. We have the Tour des Ants. The Tour des Ants runs for a length of, take note, we have 3,405 and 6 tenths km, which is kilometers. The Paris Site Marathon runs for 142 and 19 hundredths kilometers. We're going to round each distance to the nearest whole km, which is kilometer, and then we're going to find their estimated total difference. So I know that this value is about what when rounded to its nearest whole? Well, this 6 certainly makes it where we're closer to having one more in the ones place. So this is going to be 3,406 kilometers, right? It's closer to that than cutting off that 6 tenths and leaving the ones place of 5. However, over here, this one's going to round down because look, 19 hundredths and specifically 9 in the 10, or excuse me, 1 in the tenths is not enough to make us closer to having one more in the ones place. So this is closer to 142. Now, what I'm asked to actually do is to add these values together to give that estimated distance. And my estimated distance is 3,548. What was our unit? Our unit was kilometers. That finishes out the Tuesday